Hello, good evening, everyone. Good evening, good evening. Welcome to my live stream. Yes, and we are live tonight. Let's just wait for a few minutes before we start with our lessons for tonight. Yes. Okay. I didn't know what's wrong, but good evening, everyone. Yes, and we are live. Let's just chill for tonight. All right. We will start in 2 minutes. We'll just wait for our learners to be joining us. All right. Our topic for tonight is on circle theorem. We will be discussing circle theorem tonight, and if you have any question, then you can ask me. You can ask me anytime. And if you just want to be in my live stream, just chilling and listening to the music, you may stay and just chill. All right. Good evening, everyone, and welcome to our live stream for tonight. Our topic for tonight will be on circle theorem. As we are waiting for the time, let's just chill and relax. We'll start at exactly 7. Oh, it's already 7. Yay. So we only have one lesson for tonight, which is on circle theorem. This is the only topic that has been requested. So We will be doing circle theorem tonight, but if you do have any question along the way, if you wanted to clarify something, you could always drop a message on the chat box and I'll try to answer them the best that I could. All right, so we will start with our circle theorem. Okay. Oh, what happened? All right, so circle theorem. So we will be learning what is a circle, the different parts of a circle, okay? And of course, the different theorems. This is actually under geometry, and we will be discussing like the different parts of your circle, as I have mentioned, and as well as the different theorems that applies when you have inscribed polygons. So when we say inscribed, meaning inside your circle, okay? So the first one is we will recap on the different parts of your circle. So the first one that we have here is this with an arrow, this arrow here. So what is this part? This is what we call your arc. And since this is the smaller side, we call it minor arc. All right, so it's called a minor arc. The small side, the small arc will be your minor arc, or some call it arch, but it's actually an arc. And the other side, the rest of the circle, will be your major arc. And the space inside this included space between these two sides here, okay, and your arc is what we call the sector. So this is your minor sector, and the other side will be your major sector, okay? So that is what we call your sector. And the distance between your center, by the way, this is your center here, okay, we call this the center. The distance between your center and a point, or a point on your circle, on the circumference of your circle, is what we call our radius. All right. So from your center, if a segment is passing through the center, okay, like this, for example, a segment point to point from your circle passing through the center is what we call your diameter. And of course, the whole thing is what we call circumference. Okay. The line outside that is touching one point of your circle, all right? A line that is touching one point of your circle. Hi, Onika, is what we call tangent. A line that is touching a point of your circle is what we call tangent. And we have this is what we call a chord. A chord is a segment that is touching from one end to end. All right. So we have your minor arc, minor sector. This one is also a minor. We call it, hi, Ambery. This is what we call as well a minor segment. This one, this space here, is also a minor segment. Okay, so those are our different parts of our circle. So we have a chord, we have a minor arc, we have a sector, we have a radius, we have a diameter, we have a circumference, and we have a tangent. Now, why did I start with the parts of the circle? Because in our topic tonight, we will be talking about the circle theorems. So circle theorems are laws that apply to both angles and lengths when circles are involved. Okay, we'll deal with them in groups so that it will be easier for you to recall or remember. So the first one are the non-circle theorems. So we all know based on polygons that we have discussed last time. So these are the non-circle theorems, but they are very useful when we have questions involving circle theorems. So the first one is angles in a quadrilateral always add up to 360 degrees. We have learned this based on polygon. A four-sided polygon adds up to 360 degrees. Okay. And the base angles of an isosceles triangle, such as this, are, the word is equal. This one, if your sides are the same, their angles are also the same. Okay, so if the sides are the same, two sides are the same, we call that an isosceles triangle. That means that their base angles, we call these as our base angles, they are also equal. All right, I hope that is clear. So those are the non-circle theorems. Those are the non-circle theorems that are important when we talked about the different circle theorems. Okay, so let's start with the first set of circle theorems, which involves right angles. Okay, so if you have a right angles, when we have here, please do remember, tips to remember the wordings in your black boxes, because you're often required to justify in words when, particularly with circle theorems in any of your tests. If you are doing circle theorems, you will be asked to describe or justify. Hi, Kaini. No problem. So the first one is angle between radius and a tangent is always 90 degrees. So if it is a radius, that's your radius, and a tangent. Remember, your tangent is a line that touches one point of your circle. A line outside your circle that touches one point. So the angle that is between your radius and your tangent is always 90 degrees. Okay, so this one here is always 90 degrees. And an angle in semicircle. So this one is half of your circle, right? And this is a right angle triangle. So if this angle here, okay, a chord that is touching on your circle facing your diameter, an angle in a semicircle is also 90 degrees. So note that the hypotenuse here must be the diameter of your triangle. Okay, so a chord, let me just erase that so that it will be clear. This is 90 and this is also 90. So the angle that is facing your diameter is always 90 degrees. If it is inside, and of course if it's touching your circle. Okay, so that's always 90. The second set or the third set of circle theorems, these are involving other angles. So the first one was, oh, it covers, sorry, I think I have moved it too much on top. The circle theorems involving right angle, what are they? One is, it has to be 90 degrees. Okay, 90 degrees. Right angle triangle, right angles is radius and tangent, and the other one is your angle that is facing your diameter. All right, now if it is your, sorry, let me just, I think something is wrong. Okay, so if it is a circle theorem involving other angles, so the first one is angles in same segment are equal. So if you would notice this angle here, okay, this angle here that is touching one point in your circumference, and this angle here touching one point in your circumference, and they have the same segment here. Okay, this is the same segment. Okay, extended. This will be the same measure, not 90, the same measure. So let's say, for example, A here is 30 degrees. That means A on the other side will also be 30. Angles in same segment, or sometimes same arc, that those angles facing the same arc is the same measure. All right. And if you have angles, okay, if you would notice how it is being drawn is from your center, it is drawn touching one point of your triangle, sorry, in your circle, and it has been extended towards one point of your circle, okay, in your circumference. The angle here in the center is twice the angle that is at the circumference. So you might ask, Teacher Maria, what if this extended angle is somewhere here? Let me just draw. What if it was here, Teacher Maria? Will that be the same? Will it still be half? Yes, it will be. Okay, as long as they are coming from the same point of your, or same arc. Okay, so two things that you have to remember here. If two angles are facing the same arc or the same segment, they are equal. If an angle created or constructed from the center and it is being extended the same arc or the same segment to any point in your circumference, it will be twice or half. So how would that be? Let's say, for example, A here is 40 degrees. What will be your angle in the center? So if A is 40 degrees, the angle in the center will be 80 degrees. All right. Now, if your angle in the center is 120, what do you think will be the angle that is extended towards a point in your circumference? It will be half of 120, which is 60 degrees. Okay, so that is our third set of theorems involving other angles. Okay, the next set is those that are involving other angles wherein you have a polygon inside. Anything that is inside your circle is what we call cyclic. So this is what we call a cyclic quadrilateral, because it is inside your circle. It's constructed inside your circle. So opposite angles of your cyclic quadrilaterals always add up to 180. Now, you all know that a four-sided polygon, the total of this is always 360. Okay, but it's not the same, or it doesn't add up oppositely by 180. This theorem only is true when it is inside your circle and when it is touching your circumference. Okay, now what if, you might ask, Teacher Maria, would the theorem still be true if it was not touching the circumference? Let's say, for example, I have a circle and the cyclic quadrilateral is hanging like this. No, it's not even called cyclic. Okay, it has to touch the side of your circle or your circumference. It has to touch like this. Then your opposite angles always add up to 180. So how is that? How would that be? Let's say, for example, your x here is 70. So what will be the opposite? The opposite will be 110. Okay, so it's 70, so the opposite will be 110. All right. The next one is circle theorems involving the lengths. So lengths means the side or the segments. So the lengths of your tangent always from a point of your circle is always equal. So let's say this is extended to a tangent, touching one. It has a common for the vertex. This measurement is always equal, this one. Okay, from where it is pointed, where it touches, not pointed, where it touches, it's always equal in length. Okay, so if I close this, that will form an isosceles triangle. All right. Now the next one is radius is always constant in length. Okay, it doesn't change in measure. So if this is 3 centimeter, this will also be 3 centimeter. Wherever it is, radius is always the same. So this results, that's the reason why if you have from the center and this has been extended, this will result to an isosceles triangle. A radius and a radius extended. The segment here will be its base. The angles here will be equal. What have we learned? If you have an isosceles triangle, the base angles are equal. Someone is torturing your brain. Okay. All right. So if we have, let's try this. Identify which circle theorem you could use to solve the question. Okay. The question is the one from the center. Will it be angle in semicircle is 90? Will it be angle between tangents and radius is 90? Will it be opposite angles of a cyclic quadrilateral adds up to 180? Or will it be angles in same segment are equal? So identify which circle theorems. Okay. All right. So which circle theorem would help you solve this angle with a question mark? It's the angle from the center. So what have we learned? What shape does the one inside? Option number 3, yes. Opposite of your cyclic quadrilateral, yes, that's true. Option number 3, and what else? What else? Because this one is what have we learned? Cyclic quadrilateral is the opposite, right? So if this is 100, that means opposite is this one. Can you know the measure of the whole circle? Yes, it's 360. Measure of the whole circle. What do you mean? The circumference or the area? Measure of what? So if this is how do we solve? What are the theorems that we could actually use? This one is correct. Opposite angles. Let me just erase because I think I have. Okay. This is correct. Opposite angles of a cyclic quadrilateral. Oh, okay. The circumference. And you use your formula. Circumference is 2 pi r. You use this formula. So pi is actually the measure of your twice your radius, and the pi will be the measure of your circumference. Okay. So going back to the question, opposite angles of option 2, no, there's no tangent, there's no radius, so it can't be option 2. The other option that would help you, since this is 100, so this is 80 degrees, right? Because you use option 3. No. Opposite is the opposite of a cyclic. This is the cyclic quadrilateral. This is the cyclic quadrilateral here. So opposite to your, let me just clear the ink. So this theorem, option 3, would help me solve the opposite of 100 on the other side, which is 80 degrees. How will I solve the one in the center? The one in the center is option number 1, 2, 3, 4, 5. The angle at the center is twice the angle at the circumference. Remember this theorem? The angle at the center is twice this one. Uh-oh. Where is it? Sorry. This one. The angle at the center is twice. This is the theorem. So the other theorem is the cyclic quadrilateral. And so for this one, for us to solve the center, it will be 160 degrees. Okay? So the question mark or the question angle measure here is 160 degrees. Again, what are the theorems that we have applied to solve this question? First is option number 3, opposite angles of a cyclic quadrilateral is a sum of 180. So if this is 100, therefore the opposite will be 180. Always remember that a cyclic quadrilateral touches your angles at all points. Yes, that is right. So that means that the measure of the angle in the middle or from the center would be twice the measure of this. Okay, so why is it twice? Because it is coming from the same point in your circumference or the same segment. Okay, it's coming from the same segment, so the same point here, so it will be the same. All right, so option number 3, opposite, is a sum of 180, and option number 5 is twice. So if that is 80, therefore this is 160 degrees. Okay, yes, that's right. How about this one? How do you think would you be able to solve this? How do you think? What are the theorems that you need to apply to solve this? The question here. By the way, for you to remember this is what we call a butterfly effect. Okay, you would see it will form a butterfly. If it forms a butterfly, the angles, okay, the angles here will be equal. If you would notice, if that is 70, this is the opposite of its wings. That is what we call a butterfly effect. So for you to remember it, just remember a butterfly wings. So this is your butterfly. That's your butterfly. So butterfly effect is option number 4. Angles in same segments are equal. Okay, so if that is, yes, it's also 70. That's right. So if this is 70, this is also 60. Good evening, Maha Blanca. Okay, so if that is 70, the other side will also be 60. So the same side of your wings will be the same measure. So always remember, if you have this, it's what we call the butterfly effect. So that you won't forget. It's option number 4. Angles in the same segment are equal. Or in other words, that is what we call no problems. It's the butterfly effect. It's a butterfly. Okay, so yes, that is also 7. Okay, next one is identify which circle theorem could you use to solve this. So when you apply circle theorems, the first thing that you have to look into is what are the givens. That's always any maths question, any maths problem, any maths question, it's always the same thing. First, identify what is given. Second, what do you know? What are the formulas you know? How can I solve? Third is, what is being asked? So what is asked? Then you apply whatever you know about that. Okay, so here, which circle theorem? The first one is you are given a line that is outside, right? Option number 5. Okay. Lengths of the tangent from a point to the circle are equal. Yes. That's right. What else? What else? How can you be able to solve? What other theorem would apply to solve this unknown angle in the middle? What do you know about the given? The given, you're having a radius, you have a length or a tangent. What's the other one? It's option number 2. Option number 2 states that angle between tangent and a radius is always 90. So this is 90, this is 90. This is 90 degrees. This is also 90 degrees. So how will I solve the measure of the angle in the middle? Anyone? So the last one would be angles of a quadrilateral. It's the 8th one. Add it together, 6 and 5. Lengths, base angles, no. Okay, you can do that. Okay, Anika, you can do that. However, you are asked for the measure of this angle. So that will be a bit of a long range or a long way of solving it. So just remember that any quadrilateral, any four-sided is always 360. It adds up to 360. So if you have 65, if you have 90, you add that up and you subtract it from 360. What would be the difference? So 65 plus 90 plus 90 subtracted from 360 would be the measure of this angle here in the middle. Option 6 is okay if you know what is the measure of this angles here. But that is a long way to solve because you have 65 minus 180 divided by 2 so that you will get. So it's a long way to go. You answered option 6. Recount it. What? What option? Okay. Your answer is option 2, angles between tangent line. Okay. And you said that option 6 as well. Yes, that can be. But you cannot have option 5 or option 3. Option 5. No. You cannot have option 5 because, okay. Oh, okay. No, you can't have option 5. No. Because option 5 states that an angle at the center is twice its circumference, but there is no circumference angle. Always stick to the given. What is the given? There is no circumference angle. Circumference angle look like this. Okay, that's a circumference angle. An angle that is formed by two segments from a circumference point. So it cannot be option 5. It is option 2 and the last one, option 7. Okay. Why is it option 2 and option 7? Though option 5 is okay, however, we do not have this measure. But it can be used if this was given. If this was asked, I mean. The 2, if it is equal, that means that both sides will be equal as well. But that was not the question. That wasn't the question. The question mark is in the middle. So option 2, angles of tangent is always 90. So this one is 90 degrees. That's 90, 90, 90, 90. And a quadrilateral is always 360. So 65 plus 90 plus 90. Subtracted from 360, the measure of the middle angle is 115. All right, let's proceed. I hope that's clear. Okay, which angle theorem will help you solve this question? So the unknown is angle C. What is the measure of angle C? So which would help you solve this? So O here is center. So that means if this is center, this is radius. This is radius. That's radius. That's a radius. Since that is radius, this is diameter. The first one will be option number 1. All right, option number 1. Angle of a semicircle. Angle in semicircle is 90 degrees. So this one is always 90 degrees. The one that is the angle in your semicircle, that is always 90 degrees. What do we mean by angles in semicircle? Angles in semicircle is the angle that is facing your diameter. So this one is your diameter. This is your diameter. All right, that's your diameter. So therefore, the angle facing the diameter is always 90 degrees. So if this is 90, total of a triangle is 180. Semicircle total is 180, but the one facing is 90 degrees. Where is it? This one, angle in a semicircle is 90 degrees. Radius and tangent is 90 degrees. This is the theorem. Okay, so angles in semicircle is 90. Angles between radius and tangent is 90. So going back to the question, this one is an angle of your semicircle, so that is 90 degrees, not 180. I think you're confused. Opposite angles of a cyclic quadrilateral adds up to 180. but the angle in semicircle is 90, the one that is facing your diameter. So if this is 90, this is 20, what will be the measure of angle C? What will be the measure of angle C? So a bit confused ko. Okay, again. Oh, okay. All right. So this one will be 70 degrees. Okay? Because, why is it 70? Because in a semicircle, the one that is facing your diameter is always 90 degrees. So since it's already 90, and we all know that a triangle adds up to 180. So if this is 90, this is 20. So 90 plus 20, sorry, it's 110. So this will be 70 to make it 180. All right. Oh, you are just doing the intercept. I thought you were doing the circle theorem already. No problem. Okay, so which circle theorem you could use to solve this question? So the question is, what is the measure of angle S? So the first thing that you have to check is there a butterfly effect? So yes, there is a butterfly effect here. This one, this is your butterfly effect. That's the butterfly. That's the butterfly. Yes, you are right. That's the butterfly. So if this is butterfly, okay, that means that the measure of this and the measure of S will be the same. Okay? So angles in same segments are equal. Now, if you would notice, there is a line that is being drawn here. So what does it mean? The base angles of an isosceles. So again, isosceles triangle has two sides that are equal. So if two sides are equal, the two base angle that is facing that will be equal as well. So the total of a triangle is 180. So if this is 116, 180, we write it, minus 116 would be, what is 64, right? So 64, you have to divide this by 2 because you have two sides here. They are always equal. So 64 divided by 2 is 32. So this angle here is 32 degrees. This angle here is 32 degrees. And since it forms butterfly, that means that this is also 32. Okay, so I hope that was you were able to follow. All right, let me just do it again. Okay, how will you identify or how will you solve S? So the first thing that you have to do is you have to look at what is given. The given is 116 and it is sitting in an angle that forms a triangle. Oh, okay. That forms a triangle that has two sides here that are equal. So since it has an equal sign, if you will see any line, that means that it implies or symbolizes equality. So this is equal. So if this is 116 and I know that a triangle is always 180, a sum of 180, so 180 minus 116 will be the measure of the remaining angles of my triangle. So 180 minus 116, I will have 64. And since both sides are equal, that means that each angle will be equal as well. So how will I make it equal? Just divide 64 by 2, which is 32. So this will be 32, this will be 32. Sorry, that's 32. So since it's forming a butterfly, that means S is also 32. That's it. And you are done. All right. Okay. Try to solve the unknown. I'll let you try it. Try to solve. What is the value of x here on the first drawing? Try to solve it. Try to solve the value of x on the first. Okay. Do remember that if there is no, all right, if there is no center O given, that means that this is not a diameter. So if it doesn't say point O is here, that means that it's not a diameter, okay? It's just a chord. It's just a segment that is inside your circle. Please do take note. If there is no point O anywhere in the middle, that means that it's not a diameter. So what do you know? That's the first one that you have to remember. What do I know? What I know is that triangle always adds up to, a triangle angles always add up to 180 degrees. A cyclic quadrilateral, okay? A cyclic quadrilateral opposite is always a sum of, or adds up to 180 as well. So you would notice this is a cyclic quadrilateral. So how would I solve x? I can only solve x. No, it's not 70. Where is 70? Where is 70? Is it the x value or where is 70? Is that your x? 70 degrees is a B or a D? An X or the B? A triangle always is 180. So if I have 73, I have 37. Where is 70 degrees? B. Yes, that's right. So this one, that's correct. That is 70. You are right. And based on the circle theorem, no. Based on the circle theorem, opposite always adds up to 180. Opposite always adds up to 180. Not equal. It doesn't form a butterfly, so it's not equal. Opposite is always 180. So if that is 70, what's the value of x? Yes, that's right. 180 minus 70 is your x, which is, what's the value of x? 180 minus 70 is not 90. You're short, you're short. What is 180 minus 70? 180 minus 70. Again, if it is not with a point O, it's not a semicircle. So just subtract 110. Yes, that's right, 110. So x is 110. That's correct. Okay, try the other one. Yeah, that's correct. 110. Okay. Nako naman. Okay. Next one is, always remember, again, a tangent and a radius always forms 90 degrees. So this one is 90. A tangent and a radius always forms 90. So if this is 90 and the whole thing, look at the bigger picture or the bigger triangle, the whole thing is also a triangle. So if that is 90 degrees, Sorry, I think I erased everything. So if this is 90, what's the value of x? So if this is 90, what's the value of x? Always look at the bigger picture. You have a bigger triangle outside and you have a smaller triangle inside. So the bigger triangle forms a radius and a tangent, which is 90 degrees. So if this is 90 degrees and this is 24, what is x? So 90, the total or sum of triangles is 180. So 180 minus 90, which is one of the angle here, formed by your radius and your tangent, and a 24. So what is x? So x is x is 90, 24, and x is to form the whole triangle, the bigger triangle. What is x? Yes, that's correct. 66 degrees. Okay. So when you solve problems involving circles and angles, or the circle theorem, always first look at the given. What are the givens? And then you identify what are the theorems that you know that you can apply. And pretty sure it's always quadrilateral and triangles. So always remember, a triangle is 180. A quadrilateral is 360. And if it is a tangent and a radius, it's 90 degrees. So x is 66. Now, this is from center O. So these sides are equal. Okay? So what do we know by isosceles triangle? Isosceles triangle with equal sides also have equal base angles. The measure is equal for your base angles. So if this is 66, what is the measure of y? What is the measure of the angle? 180 minus 66 divided by 2. The answer, you divide it by 2 because that is an isosceles. No, y is not 90. Your x is already 66. Your x here is already 66. This one is already 66. And you're asked for this. 57. Yes, that is correct. 57 degrees. Yes, that's right. That's right, Kaini. So 66 minus 180. The answer divided by 2 will be your y. Why is it 57? Because these two sides here are radius. So same measure of the sides, same measure of the base angles. Wow, well done, well done. Can you try to solve this? We're almost done, we're almost done. Try to solve the following. Type in your answers. Let me know, let me know. What is the measure of angle x on A, angle x on B, and angle x on C? Is it clear? I hope it's clear. What's the measure of angle x? If opposite is 85, what will be the measure? Remember, opposite angles of a cyclic quadrilateral, anything that forms quadrilateral inside is adding up to 180. You are short of a number. Close to the correct answer, but short. This is 85. If opposite adds up to 180, what will be x? It will be 180 minus 85. That will be x. 180 minus 85 would be your x. So if D is 85, what will be your x? Yes, that is correct, Kaini. That's 95. Yes, x is... What's wrong with it? What's wrong with my pen? X is 95. That is correct. How about letter B? That is a butterfly. So what will be the value of your x? Don't be deceived by the givens. What will be the value of x? Same point of your wings of your butterfly will have same angle. So what will be the value of x here? Correct. It's 51. That's right. That's right. That's correct. Okay. One more. If this one is 150, what will be the value of x? Remember, the angle from the center is twice the angle from the circumference. Same segment or same arc angles, the angle from the center is twice the angle from the center. The angle from the center is twice the angle from the circumference. So if the angle from the center is 150, what will be the value of x? Circumference is this one. The one that is touching your circumference. This is what we call the circumference. If it is in polygons, it's actually the side, but circles doesn't have sides, so they call it circumference. Yeah, so that's the circumference. The angle at the circumference, that's the circumference. This is the circumference. This angle is twice the circumference. So what will be the measure of your x? The angle at the center is twice the angle at your circumference, given the same segment, the same arc. So if this is 150, that means x will be half of it, because this is twice x. Not the angle from the center is twice. Inhale, exhale. If this is 150, therefore x is half. because the angle from the center is twice. Yes, that's right. It's 75. Okay. Again, let's just do a recap. If it is a cyclic quadrilateral, as this example in 1a, opposite angles are always a sum of 180. So if the angle on the opposite side is 85, so 180 minus 85 will be the measure of the angle opposite to it, which is 95. And letter B, angles from the same segment or arc, or the butterfly effect, will have the same measure. So if this is 51, the other measure would also be 51. Third one, letter C, the angle from the center is twice the angle from the circumference of the same segment or same arc. So if the angle measure here is 150, since this is twice, that means that this is half of 150. So that means that is 75 degrees. You're getting it? Okay, let's do the last. I think this is the last one. Yeah. Try this. Only 2 questions. I think we'll not be playing Kahoot tonight. Let's just chill and finish the 1 hour live stream with this question. It's so nice to be challenged. It's so nice when you are doing maths question. It's good to be challenged with questions and try your best to answer them. Okay? You will be okay with maths if one is you just follow the steps. What is the given? What do you know? How do I solve it? Know using what I know, and then what is being asked. The only problem there is if you do not know what you are doing. 250? How come? Okay, this is 110. As I have mentioned, this is your cyclic quadrilateral. A cyclic quadrilateral is always the one touching your circumference. So if that is 110, what would be the measure opposite to it? If that is 110, what is the measure opposite to it? This will be 70, right? This one will be 70. So what is x? Cyclic quadrilateral in a circle. This is 110. Opposite will be the sum. That means that is 70. So if this is 70, what did we say about the measure of the center angle? It's always twice the circumference. So what is x? It's not 250. Good try, Kaini. But it's not 250. Yes, that is correct. Well done. It's 140. What happened to my... Okay. It's 140. Yes, 140 degrees. X is 140. Okay. Now let's go to the last one here. This one is a quadrilateral, okay? Not cyclic. Cyclic only applies when it's inside your circle. Anywhere else that is not inside your circle, we call them quadrilateral, which adds up to 360, right? The sum of the interiors of quadrilateral is always 360. This is 80, not 180. This is 80. And if you would notice, you have a radius touching your tangent. The angles formed with your radius and your tangent is always 90 degrees. So that's 90. This is 90. So what's the measure of x? A and C are 90 degrees because these are angles formed by a radius and a tangent. So that is 90, 90. So what will be the value of your x? What's the x value? Again, a radius. The angle formed between your radius and your tangent is 90 degrees. A quadrilateral, okay. Yes, that is correct. X is 100 degrees. Yes. Well done, Kaini. Yes, that is correct. Okay. So just to recap, I hope, I do not know. Yeah. Okay. Just to recap what we have learned tonight, if you have a circle, all right, and if you have a cyclic quadrilateral, when we talked about cyclic quadrilateral, that means that it's touching the circumference of your circle. Opposite angles always adds up to 180. Okay, if you have a circle, from the center you have your diameter, and this forms a triangle inside. Opposite to your diameter or your semicircle angle is 90 degrees. If you have a circle from the center, the angle formed from the center is twice the angle of your circumference angle. So if this is 60, that means that your circumference angle will be 30 degrees. If you have a circle and if you have an angle formed between the same segment or same arc, or we call this the butterfly effect, the angle measure are equal. So if this is 30, this is also 30 degrees. All right. And if you have a circle and you have a tangent from the center to that tangent point, it forms 90 degrees. And it forms isosceles with another radius. Questions so far before we end our session for tonight? I hope that you have learned something tonight. Please do leave a comment if you have any other topics that you would wish me to cover, whether it is in science or in maths. We will cover both science and maths. So please do leave a comment or leave your topic that you would wish me to cover, or if you would want me to make a video out of it, please do leave a comment in any of my videos. So please do check out my other videos as well. All right, so I hope that you were able to understand. Yes, I have. Okay, what is it, Kaini? What's your question? Kaini has a question. Is it a question, Kaini, or is it a topic? Let's just clear this out. All right. Please make a topic about arcs and stuff. Okay, arcs and stuff. Okay. Arcs. What do you mean by arcs? Circle. Oh, okay. Make a topic about circles. All right. Okay. Will do. Will do. Like finding angles. I just did. I just did. Okay. Yes, sure, Ambry. Finding angles. All right. Thanks, everyone. Thank you for being with me tonight. Thank you for being here in our live stream. I hope that you were able to understand, and I hope that you have learned something as well tonight with regards to circle theorems. And for those that are new to my live stream or even to my channel, please don't forget to subscribe to my channel and hit that notification bell so that you would know when our next live stream and next video be released. By the way, I normally release videos not normally, but I do release my videos in my YouTube channel every Sunday morning. So please do watch out for the next video this coming Sunday. I just released, I think that was on fun facts. So probably by next week, we will have our art. Okay, so thanks everyone. Yes. Thanks everyone for being here tonight. Thanks for being present in our live stream tonight. And I hope to see you next week again. Once again, this is Teacher Maria saying God bless and take care. See you next week, everyone. Bye. Thanks, everyone. See you next week.